I'm going to use subscripts, 3 potassiums and 1 phosphide. I'm going to show you the crisscross. Do you like this? Take this number here. This number becomes that subscript. How do you write the formulas for ionic compounds? Well, these are the rules. You may want to copy those down. First, you're going to write the cation and anion, and then we're going to put those subscripts in there to show how many of each. And here is the whole deal. The total charge of this compound has to be 0. It's kind of like on a zipper. You know how like the number of teeth on the left and the right have to match up? That's what has to happen. The total charge has to be complete so that there is no charge left over. And then we may need to use parentheses to show multiple polyatomics. So I'm going to teach you through 2 examples. Just work these with me, and I think these rules will make more sense. So plus thing is write the cation and the anion. I recognize potassium is a metal, and that forms the K+ ion. Phosphide is a nonmetal, and that is a 3-. Now, how many of each do I need to make the total charge 0? Will one of each work? No, that won't work. I need more potassiums. So I need 3 potassiums. So 3 times +1 is +3. And then I'm going to add in that -3, and I get 0. So I'm going to use subscripts, 3 potassiums and 1 phosphide. So there is an understood 1 right there, meaning 1 phosphide, but we typically don't write that. Like you don't write X to the first, right? So this is how we show the formula. 3 potassiums, 1 phosphide. Do you notice there are no charges? No charges in a compound, because what is the total charge? 0. All right, let's do it again. Aluminum makes a 3+ ion, as does other elements in that group. And then nitrate is one of our polyatomics. So look that one up. NO3 has a -1 charge. Now, I'm going to need how many nitrates to balance out that +3 aluminum? I'll need a total of 3. So 1 aluminum, and we will need 3 nitrates. Now let me show you what happens if I don't put the parentheses. I'm just going to show you this so you'll understand. What if I put that? That looks like 1 aluminum, 1 nitrogen, and 33 oxygens. That's not what I mean. So what I need to do is put parentheses around the nitrate. And so that 3 right there on the end means 3 of everything in the parentheses. So the nitrate stays bonded together, and I need 3 of them to balance out that aluminum charge. So this is aluminum nitrate. 1 aluminum, 3 nitrates. Let's do a couple more. I'm going to go ahead and write these ions down so that we can have those ready to go. Nickel 2. Okay, here we go. Remember, the name of the game is to balance out the charges such that the total charge is 0. So let's go ahead and do the easiest one. Ammonium chloride, +1, -1. Well, that's easy. I need 1 ammonium and 1 chloride. Make sure you don't drop that 4 right there, because guess what? That whole thing right there, that is ammonium. It's a nitrogen with 4 hydrogens bonded to it. So that's ammonium chloride. All right, calcium nitrate looks pretty easy. I've got 1 calcium, and I need 2 nitrates to get a total of 0. Calcium bromide, well, I've got a +1 and a +2 and a -1. So 1 calcium and then 2 bromides. That'll add up to 0. Here's your check. Here's your algebra check. +2 plus 2 times -1 equals 0. That's what you're doing in your head. These are simple integers that you can add up in your head. Now this one's a little interesting. I've got a +2 and a -3. How do we get that to balance out to 0? I'm going to show you the crisscross. Do you like this? Take this number here. This number becomes that subscript. This number becomes that subscript. Watch this. We're going to have 3 nickels and 2 nitrides. So basically what we're doing is a least common multiple. How do you get 2 and 3 to match up? You got to get to 6, right? So 3 times plus 2, oops, sorry. 3 times plus 2 plus 2 times -3 gives you 0. So what we're doing is we're balancing the charges until we get the total charge of the compound to add up to 0. Now look, this takes a lot of practice. Don't be discouraged. Go through it step by step. And then the last thing, look at your compound and make sure that you don't have any charges in your final formula of your ionic compound.